Okay, I'm going to start the webinar.
Morning, everyone. Looks like we got some people coming in.
Yeah,
Like we've already started the flow of people coming in, so since this is recorded, I'll get going with the questions. We have one from Stephen Posta from Spring, Texas. Next generation space-based telescopes already have 4 projects being by NASA. The Origin Space Telescope and the Link X-ray Telescope. Link's X-ray Telescope.
Hey, Mark, I think there's something up with your audio because I'm not hearing it.
Oh. Yeah, it's cutting out really bad. Uh-oh. Yeah, you froze, Mark. Shall I ask a question until Mark gets his...
Yeah, why don't you ask the question until he gets back up and running?
Oh, yeah, Mark, you might want to, I don't know, restart or something. Yeah, Stephen Poston from Spring, Texas. He asks, the next generation of space-based telescopes already have 4 projects being studied by NASA. They are the Far Infrared Origin Space Telescope, the Lynx X-ray Telescope, the Habitable Exoplanet Observatory, and the Large UV Optical IR Survey Telescope. Which of these excites you most and why?
Well, there's a 5th one that you could add to the list that's called LISA, which is where they're going to put a radio telescope up in space, far away from the Earth, and basically increase the baseline of the very long baseline interferometer array. Because right now, the highest resolution telescope available to humanity is a network of about 8, well, it's actually now 13 radio telescopes around the world where they get the equivalent resolution of a telescope 5,800 miles in diameter. But the goal is if we can put another radio telescope out, say, 1,000,000 miles away from the Earth, or even 500,000 miles away from the Earth, that would dramatically increase the resolving power that we would have. Interestingly, that would be the cheapest of the 5 proposals. And I think it will deliver the greatest science. And so that's the one I'm most in favor of. But to be clear on this, none of the 5 are funded. They've all been proposed, but none of them have the funding yet. All of them have value. Astronomers are promoting that, hey, it'd be good if we could actually have all 5 in place. But likely we might get 2 out of the 5 funded. But in my opinion, the one that's most deserving of funding would be, hey, get a radio telescope out there. It doesn't have to be that big. The key is to get a significant baseline. So instead of being constrained to the diameter of the Earth, we could actually have a telescope. Because I mean, if you link that one up with the 13 that are already on the ground, you're going to get a very extremely high resolution telescope, a telescope that will be able to make observations to better than a 10,000th of an arc second. That would be phenomenal, because that would give you really accurate distance measurements out to billions of light years away and super accurate measurements within our own galaxy. Oh, we got Mark.
On?
Yeah, back on, and we can hear you.
Okay. I don't know what happened, but I got kicked out of Zoom, so something went bad. Okay, it looks like Tim Williams' question is regarding the 2002 paper the disturbing implications of a cosmological constant. What were the disturbing implications? And 20 years later, are they more or less disturbing?
Yes, I got the paper in my briefcase here. I could actually haul it out. So I carry it around with me. But it's a paper that was written by 3 theoretical physicists. All of them are public atheists. And the paper is basically saying, hey, if dark energy is real, if it actually exists, then we have this causal agent beyond space and time performing miracles for reasons of his own. They basically agreed that if dark energy is real, it requires extraordinary fine tuning. In fact, a degree of fine tuning that's greater than anything else we can measure in any of the sciences. And so, as atheists, they said this is highly disturbing. The fact that if dark energy is real, then it means we have this agent beyond space and time performing design miracles for reasons of a specific purpose. So they concluded their paper saying, this is so utterly disturbing, dark energy cannot be real. It was published back in 2002, and the irony was, well, it was back in 1999 when the first real evidence for dark energy came out. But literally within 9 months after that paper was published, astronomers came up with 9 independent astronomical demonstrations that not only is dark energy real, it's the dominant component of the universe, which means we really are stuck with an agent beyond space and time performing miracles for reasons of his own. And if you go to reasons.org, we actually have a place where we've archived not only 9 short articles I wrote on about those evidences that dark energy is real, it now has 25. So that's what's happened in the intervening 20 years. We now have 25 independent astronomical demonstrations that dark energy is real and the dominant component of the universe. What has changed is back in 2002, there was quite a bit of debate about whether this dark energy discovery is going to stand up. The debate is now over. Astronomers around the world, there's a consensus. Dark energy does exist, and it makes up about 70% of all the stuff of the universe. However, a lot of astronomers are not aware of that paper published in 2002, which is basically saying, even from an atheistic perspective, if dark energy is real, it establishes that there has to be a God beyond space and time who designed the universe so life can exist in the universe. So yeah, often when I speak on university campuses, I will cite that paper, basically making the point, hey, it's no longer just Christian astronomers that see these theological implications in dark energy. It's now agreed upon even by people who are committed to an atheistic worldview. But dark energy is real, and the implications indeed still stand.
Thank you. Stephen Posta from Spring, Texas asks, is there a single diagram that shows many or all of the major geological astronomical events of Earth's history? The timeline on this diagram would include things like when various past ice ages occurred, major asteroids impacted the Earth, major animal groups appear, etc. And if that diagram exists, can you share it with the paradoxes class?
No such diagram exists. That sounds like a great homework assignment for Stephen Posta. Go through all of our books and produce such a chart. What we do have on our reasons.org website is a timeline chart that basically shows you the events that are described in Genesis chapter 1. And we will have the dates listed there, but also we put the error bars on those dates, because I remember the first time we brought that chart out, people thought the dates that we had on the chart were exact. No, we don't have precise measurements. Well, we do for some of the dates. For example, for the origin of the Earth and the origin of the universe. But a lot of the dates we see described in Genesis 1 we don't yet have really precise dates for. But yeah, Stephen, that sounds like a great idea. Let's actually develop a big chart. It probably would fill a good chunk of a wall where you have all those events listed there. But to make it useful, we not only have to list the events and the dates, we also need to indicate the error bars on the dates so that people don't overinterpret the chart. And hey, if someone wants to help Steve with that project, we used to do that a lot in Paradoxes where somebody would come up with a great idea and say, Hugh, this would be great for you to do. I say, yeah, but I don't have the time. And we turn it into an assignment. And often we get some really good results. So
Thank you.
Steve, you don't have the time, maybe someone else in the class does.
Yeah, we have a lot of smart people in this group.
There are.
Tom Way from Germany says, I have a very nice, inexpensive, bilingual, leather-bound Chinese English Bible that was printed on thin paper in China. It uses the English Standard Version, which translates Rakia, R-A-Q-I-A, of Genesis 1 as an expanse. Have you ever examined this version? And would you recommend it for Asia Pacific readers who might prefer it over recent American revised versions?
Yeah, the English Standard Version, it's a relatively new Bible translation. And yeah, conservative evangelical theologians give it a lot of praise, particularly since the 2011 New International Version has altered a lot of the translated words that were in the 1984 version in a manner that's not conducive to a conservative interpretation of the Bible. And so I'm increasingly seeing that the ESV is replacing the NIV. But hey, I still got my copy of the 1984 version of the New International Version, and I really like it. I'm not so happy with the 2011 version. But the problem is you can't buy the 1984 version anymore. You can only buy the 2011. So thanks to a member of this class, I actually got my 1984 version rebound because it was falling apart. And I intend to keep it that way because, and by the way, you've got lots of alternate translations. The Holman Christian Bible has come out with a really good translation. So yeah, we got options these days. And if you go to BibleGateway.com, they will give you more than 40 different English translations of the Bible. They're all available free online. You can search and link. And so if you ever have any concerns about, hey, how do you interpret a particular passage of the Bible, you can go there and you immediately can see all 40 plus translations, how they translate that verse. And if you want, you can go direct to the original Hebrew and the original Greek and parse all the word definitions and the grammar. So yeah, we English readers have a wealth of tools that we can use to dig into the precise meanings of the text.
It's a fantastic advice. I know when I'm studying the Bible, I never use just one version. I'm always using at least two, and I love to go back to the original Greek or the Aramaic or the Hebrew. It makes such a big difference. Even though I don't speak the languages, it's just fun to look at the interlinears.
Well, Mark, thank you for that statement because yeah, we who speak English, this is something anyone can do. It's not difficult to do. So yeah, don't depend on one translation and take advantage of all the online free aids that are out there.
Chris Thompson from Anchorage says, about a year ago, I asked you about Elon Musk's constellation of satellites, and since then, it appears they're beginning to interfere with Earth-based astronomy.
Yes.
Any follow-up thoughts, and why is the astronomical community unable to have an impact here?
Well, the astronomical community is getting a lot louder in their protests. In fact, I just saw something in the latest issue of Nature where they're saying, hey, we got to do something about this. And, you know, my friends who are still active in observational astronomy, they're telling me every time they take an image, they have to process that image and take out all the satellite tracks. And it's one thing to take out 1 or 2 satellite tracks from your image, but if you got 15 of them on there, it really begins to spoil what you've got in the background. And so it's causing an increasing problem for astronomy and at all wavelengths, because it's not just, and so they're making statements like, hey, is there a way that we can put satellites up there that are not so reflective? In other words, put anti-reflective coating on them so they don't show up as bright in the sky. And is there a way we can clean up all the dead satellites that are up there? Because those dead satellites are still reflecting light. And so, and it was one thing when we had, a couple of dozen satellites up there, but now we got tens of thousands of satellites up there. And I think I've also heard that more than half of the satellites that are orbiting the Earth are non-functioning. So they're basically saying, hey, when nations send up a satellite, we need to have them equipped with something where when they no longer are able to function, they are programmed to crash into the Earth and burn up in our atmosphere so they don't stay up there reflecting light.
Good, thank you. I have a question from Vaughn Mancha. It says, have you seen Leonard Susskind on YouTube saying, no one thinks the CC is just luck? And I'm not sure what the CC is, a cosmological constant or something, I'm not sure. You know what that might refer to?
Yeah, I would need to look at it to see what he means by CC. It might be the cosmological constant. Knowing Leonard Susskind, it might refer to something about quantum gravity. So yeah, I need to check that out.
Okay. Well, with that, Hugh, we're at the beginning time of your seminar.
Okay.
So if you could open us in prayer, and then we'll be happy to hear what you have to say today.
Okay. Well, Father in heaven, we do thank you for giving us another day to live here on planet Earth. And Lord, I pray that this day we would submit our hearts to you to receive your light, your love, life, and truth. And Father, encourage us that we can be transformed by one another. Help us to listen to one another, to hear your Holy Spirit speaking through one another. And Father, I pray that this next week we would be of full service to you. In Jesus' name, amen. Okay, I'm going to share screen so that you can see my visuals. And everybody seems to be liking the way we're doing the second Q&A session. So we'll do that again, but I do appreciate hearing comments that you might have about ways we can improve it. But just like with last week, when I'm done with the teaching time, which will run about 30, 35 minutes, we'll have a second session of a Q&A. And what we've been doing in the past is follow up that second session with a time for people to share with one another, give testimonies. We're going to blend those two together. So just like last week, once we're done with the teaching time, we'll transition from the webinar to a web meeting. I'll give you the URL for that web meeting, but in that meeting, you can turn on your cameras and your microphones. You don't have to. And so, feel free to be anonymous. We'll let you do that. But we're going to kind of transition during that web meeting from taking a question from the chat. So if you don't want to ask your question verbally, you can put it in the chat. We'll go from a chat question to a live question from someone who's got their microphone and camera on, and then to a testimony. So we'll do that once we get to the web meeting, but right now, let me share screen. So here we go. Okay, this is my first slide. And again, it's just a reminder, you don't get to ask your questions during the paradoxes class. I do take questions on Facebook and Twitter, and a lot of questions we answer through our YouTube channel, which you can subscribe to. It's free 24/7. And also I have on the reasons.org website, I've answered, I think now 120 questions in a feature called Questions from Social Media. So you can look for that under publications, and a lot of questions are written there. Feel free to share that with other people. And this book, More Than a Theory, is a quick summary of our testable creation model. It's actually a summary of 9 of the books that we have published, and you can get a chapter of that book free at reasons.org/Ross. And this is a DVD that we produced in Dual Revelation a few years ago, where we interview a number of scientists and theologians on the subject that we're talking about in a class right now. And this is the link you're going to need to get into the Zoom meeting. It's the same link we've been using for the past several months. It's also posted at paradoxes.org, and we'll have Jamie or Mark put it in the chat so that you can see it there. And I'll pop this up again just before we exit the webinar and go into the web meeting. And today we're going to get into the scientific method, what I actually prefer to call the biblical testing method. But before we get into that, I'm going to back it up with a story of, and it has to do with something that, well, let me set this up here. You know, it's not enough to take the Bible's creation science text literally. We also must interpret them consistently. I shared this last week, so I'm just going to zip through this pretty quickly. And how many church controversies would disappear if Christians would integrate all the biblical creation and science texts. This is what's unique about the Bible. It's not just 1 or 2 texts. It's more than a couple of dozen. And therefore, we need to integrate all of them. And likewise, many creation evolution disputes would be resolved if scientists would integrate across all the scientific disciplines. And in past recordings of this class, I showed, for example, how if you integrate paleontology, genetics with astrophysics, you get quite a different perspective on the history of Earth's life than you would if all you look at is the paleontology or the genetics. And last week, we finished with this slide, how even more resolution would be achieved if both the book of nature and the book of scripture were fully integrated through the application of the biblical testing method. And how you would get still more resolution would be achieved if both theologians and scientists consistently applied the biblical testing method to their studies of the Bible and nature. And with that, I want to give a little story. This goes back, almost 2 decades. And I got invited to go to the University of California, Berkeley, to participate in a weekend event, which was going to be a dialogue between leading theologians and leading scientists. When I arrived on the campus, by the way, I was told I was going to need to give a message on the scientific method there to that group. So I was scheduled to speak to the group, but to be there for the whole weekend to facilitate this dialogue between physicists and theologians. And when I arrived on the campus, where there was this big, long table in the room, and on one side were 15 physicists, and I sat on that side. On the other side, there were 15 theologians. And these are some of the biggest names in physics and theology were there. And it was a physics professor at UC Berkeley, who was a Christian. That was a co-host. The other co-host was Thomas Torrance. He's passed away, but at that time, he ranked as one of the world's leading and most famous theologians, and the founder of the Scottish Academic Press. And so he and this UC Berkeley physicist were the hosts for the meeting. And what I noticed right away is that even though the 15 physicists and the 15 theologians were seated opposite one another, separated by only 3 feet, it was clear that there was a lot of tension in the room. In fact, you could just hear silence. And so the physicist from the UC Berkeley spoke first, and it was clear he was a theistic evolutionist. I knew that ahead of time, and he was trying to say to the whole audience there, hey, we know the evolution of life is a naturalistic event. Once we get life on planet Earth, it evolves into human beings, and tried to persuade all of this that this was compatible with the Bible. The thing I noticed is the physicists weren't really buying it, and neither were the theologians. And then Thomas Torrance got up and spoke, and gave a really good message about how, we should be able to facilitate a dialogue because we're both using the same interpretive tools for the study of the Bible and study of the universe, the realm of nature. Then they had me get up and speak about the biblical testing method and or the scientific method and how it's portrayed in the early chapters of Genesis. And then we began to get some dialogue going. And what really happened, it took about 3 hours that first day for the ice to be broken. And so Tom Torrance and I basically told stories. We're the only two there besides the UC Berkeley physicists that had some experience dialoguing with both physicists and theologians. And Torrance told a story about how he would frequently speak before audiences of physicists in Britain and talk to them about the beauty in nature and how the beauty in nature reveals God. So, but by the end of that weekend, people were relaxed, they were talking to one another, dialoguing with one another, but the core of what made that dialogue possible is that even though the physicists, with 2 exceptions, had no training in philosophy and theology, and how the theologians on this side, none of them, except for Thomas Torrance, had any training in science at all. And so it was difficult, but by the end of the weekend, we were able to converse easily in friendly ways with one another because we realized we really are on the same page and that we're using the same testing methods for looking at. And it was interesting. I had a private meeting with Tom Torrance. And by the way, he was aware and I was aware that we have major disagreements on theology. He's basically one who was promoting the theology of Karl Barth. And I'm not particularly a fan of Karl Barth. However, what was interesting is that in dialoguing with the UC physicist, who is a believer, he was quite stunned that I believed in biblical inerrancy, whereas found Torrance, in spite of the fact that he was a Barthian theologian, was open to the idea of the biblical inerrancy. And so we were having a conversation there, but it ended up with Tom Torrance saying, I've been watching you all weekend, Hugh, and what I can tell is you really have a passion for bringing unbelieving theologians to faith in Jesus Christ. And he said, my experience, at least in Europe, is the majority of theologians, people who earn their living from doing theology, are not believers in Jesus Christ. They think they're Christians, but they really are not Christians. And he said, my passion is to lead physicists to Christ. I see you have a passion to bring theologians to Christ. And he joked with me and saying, Hugh, you got a much more difficult task because at least these physicists know they're not believers. The problem with the theologians, they think they are believers and they're really not. So I say all that as a way of introduction to the biblical testing method. Now, another story I will tell is that, I had been educated in public schools in Canada and British Columbia in particular. And It was there that I got taught the scientific method. And I thought this was normative when I came to the US, but I discovered it's not normative at all. I got taught the scientific method when I was in grade 1. I've yet to meet an American that was taught the scientific method in their grade 1, in private or public school education. I got taught it again in grade 2. I got taught it in grade 3. Every year we got exposed to the scientific method. And every year they describe the scientific method in more detail than the previous years. And we were taking science classes and doing lab exercises in our public schools. They always made sure that we did our lab experiments in the context of the scientific method. And so when they set up the laboratory experiments, the whole focus was, okay, here you're putting the scientific method into practice, and we're consciously following the scientific method in the different experiments and observations we're making. And when I came to the US, I discovered you got people who are in graduate school pursuing PhDs in science who don't think that way and haven't been really trained to any great extent in the scientific method. But I literally got it all 12 years. Now, what my public school teachers never shared with me, though, is the origin of the scientific method. And I kind of discovered it on my own. In my last year of public school education, when I was in grade 12, I was 17 years of age at the time. That was the first time I ever picked up the Bible to give it any kind of a serious read. Began in the first page of the Bible, Genesis chapter 1, and I immediately saw the scientific method in Genesis 1. And people say, Hugh, how did you do that? Well, it's because I've been so saturated in the scientific method, I think it was easy for me to recognize it right away when I got into the first chapter of the Bible. We'll get into that in more detail probably next week. But what I want to do right now is to take you into the steps of the scientific method. Okay. And I got this right away in grade 1. First thing you want to do is identify the phenomenon or the phenomena you want to investigate with your experiments or observations. Is basically define the experiment, define the goal, and in the experiment or the observations, determine exactly what phenomena are you wanting to investigate. And it could be more than one, because sometimes 2 or 3 phenomena are related to one another. But you don't want to look at a whole lot of phenomena. You want to just pick a few and sometimes just one. And then step 2 of the biblical testing method is identify the frame of reference, what lay people may refer to as the point of view. From what viewpoint are you going to be interpreting the experiment or the observations? What is the frame of reference from which you're going to be making your measurements? And then step number 3, you want to determine what are the starting conditions? What are the initial conditions? And so, before you do the observations or the experiments, what are the starting parameters? And you try to identify these in as much detail as you possibly can, because after all, when you're done with the experiment or the observations, you're going to be looking at the final conditions. And to really get anywhere, you really want to, as carefully, as accurately, and as much detail as possible, determine what those starting conditions are. Now, all the while, this is something that was drummed into us in my public school education. You're not interpreting. They said one of the biggest mistakes you can make in the scientific method is to jump to an interpretation too quickly. So it's basically saying step 1, step 2, step 3, there's no interpretation going on. Discipline yourself not to make any initial interpretations. And then step 4 of the biblical testing method, aka the scientific method, is to note as completely as possible what occurs, when it occurs, where it occurs, and when in what order it occurs as you make the observations, as you make the experiment. And they tell you, Always bring a notebook to you when you come to the lab, because what you're going to do in the notebook is you're going to be writing down, okay, this is the phenomena I'm investigating. This is the frame of reference from which I'm going to be doing the experiment. These are the starting conditions before I perform the experiment. And then you want to have the greatest amount of notation for what happens during the experiment or the observations. Noting as completely as possible and as much detail as possible what is occurring, when are the events taking place, where are they taking place, and in what order. And at this point, no interpretation is going on. And he said, you have to resist the temptation to interpret while you're doing the experiment. And this happens. I've seen this happen with leading scientists. They're doing the experiment, they're making the observations, they get so excited about what they're seeing. Instead of kind of writing down what's going on in as unbiased and as objective a fashion as possible, they're jumping to an interpretation. And so it was drummed into me at an early age. Don't do that. Put that aside. And then number 5 is you note what are the final conditions. And so you perform the experiment, you've done the observations. And by the way, I'm talking experiment and observations here. This just as well applies. I call this the biblical testing method because when you're going through the Bible, you're not doing an experiment, you're not doing an observation per se, but you are looking at text. So think of reading the text as making an observation or performing an experiment. And so you're reading the text. And so number 5, note what the final conditions are. Again, as specifically in as much detail as possible. And then you want to note what's different about these final conditions compared to the starting conditions. So you write this down, but you particularly compare those final conditions with the initial conditions. Okay, all the way through these first 5 steps, you discipline yourself not to interpret. No interpretations going on here. We would make so much headway if we could just simply discipline ourselves not to interpret too quickly. Okay, step number 6. This is when you now have permission to begin an interpretation. And so based on these first 5 steps, you form an hypothesis about what has occurred during your reading of a biblical text or the reading of some extra biblical text or the experiment or the observation. And we call it an hypothesis because it's an initial interpretation. And again, this is drummed into me in my public school education. An hypothesis is a lightly held interpretation. And so we were taught, do not put any emotional investment into your initial interpretation. And so it's a tentative hypothesis, no emotional investment. They said, if you put an emotional investment into this, as you'll hear from Mark Perez, this is when you begin to run a risk of committing a fallacy. And Mark, we're going to schedule him sometime to talk to you about all the different kinds of fallacies. I know he's done that in the past, but he's actually got a whole course he could teach on that. So you form a lightly held hypothesis with no emotional investment. And by the way, I'm aware that takes a lot of discipline. We're all tempted to make an initial hypothesis and basically own it. Say, hey, look what I've discovered. And says, no, don't invest that way. Keep your emotions out of it. This is a lightly held hypothesis. And step 7 is probably, and this is what, a couple of weeks ago, we talked about all the different ways the Bible talks about testing. We spent a whole Sunday just going through the entire Bible and looking at all the places where it exhorts us to test. And basically, I kind of led up to this scientific method by saying, as you look at these different biblical texts, Old Testament, New Testament, it's always followed by telling you, okay, put everything to an objective test, but here's how you go about putting it to an objective test. So that's the theme you see throughout the Bible. And if you weren't here for that, it did get recorded. You'll find it at paradoxes.org, so you can go there and listen to it or watch it. And sometimes you might want to watch it again. But yeah, you're testing your hypothesis. You're lightly held with no emotional investment by further observations, experiments, and or texts. And this is what really separates the Bible from the other holy books of the religions of the world. You know, I looked at those other holy books before I went into the Bible. And when I noticed when I got into the Bible, hey, it doesn't have just one or two texts that deal with the subject of creation and science. It's got more than 24. And the texts are lengthier than what I found in these other books that undergird the major religions of the world. I also noted that the books that come the closest to giving us multiple texts were those that were based on the Bible, namely Islam and Mormonism. Both Islam and Mormonism, as I said before, probably more accurately referred to as Christian cults, because what they do is they take the Old and New Testament and they add on to it books that they think are compatible. I don't believe they are compatible, but one reason why we do see not just one text on creation, but three texts on creation is because they're based on the Bible. But if you look at the Old New Testament, I've documented 27 places in the Old New Testament where you get a half chapter or more of content on the science and creation, which means, for example, when you're going through Genesis 1, there are going to be 26 other texts you can go to test your hypothesis. And likewise in science, we're looking at God's book of nature. Okay, you performed one experiment. You want to test that hypothesis that you developed based on one experiment by multiple more experiments. And you want to repeat the experiment exactly as you've done to see if you get the identical result. And that's something you see in the scientific literature. If your hypothesis cannot be affirmed to some degree by the same experiments you perform where you get the identical results, you're not going to get your paper published. And so getting repeatable results is a key component of the biblical testing method. So you want to repeat the experiment exactly as you did it to see if you get the same outcome. You also want to repeat the experiment where you slightly alter the parameters of the experiment and see what you get, to see to what degree you're going to get results that are close to what you got with the experiment you first performed. And you know, in astronomy, we can't do experiments on galaxies and stars and planets, but we can make observations. And so we observe a galaxy, we see certain features and say, hey, I think this is what's going on in the physics of the galaxy. But you want to test your hypothesis about the physics going on, excuse me, what's going on in that galaxy by saying, hey, let's look at a bunch more galaxies. Let's find some galaxies that look similar to the one we observed and some that look a little bit different and see what we get. So you're testing your hypothesis by further observations and experiments. And when we say further observations and experiments, we're not just talking 1, 2, or 3 additional experiments, but literally hundreds of additional experiments. And you see this in the scientific enterprise, that in terms of testing a possible interpretation of a physical or a chemical phenomena, the scientists as a community will literally do hundreds of independent observations and experiments. And you see this in Christian theology. You look at the theological literature, hundreds of theologians will weigh in with their different interpretations of texts, and they'll be bringing different texts in. And sometimes they bring in texts, you say, how can that possibly be related? But they show you that it's related. So that's another point. Some of the biblical texts we might cite may not seem related, but be open to the idea that they might be related, at least to some degree. Step 8, having tested your hypothesis by further observations, experiments, and or texts, you want to revise and refine the hypothesis accordingly. And I could add another word: revise, refine, or eradicate. Because sometimes when you do the additional observations, experiments, and tests, you say, I really blew it. I really made some major mistakes here. There's absolutely no warrant to my hypothesis whatsoever. So you reject the hypothesis. Another case is just saying, wow, these other experiments, observations, and texts, they mean that we have to make a major revision to the hypothesis, which means you keep some components of your initial hypothesis, but you're basically replacing major components in your hypothesis with a completely different hypothesis. Then there are cases where these other experiments, observations, or reading the text means, hey, I did pretty well on my initial hypothesis. All that's really is necessary is refinement. The key here, though, is if you've gone through step 7 and you say, gee, there's nothing to revise or refine whatsoever, you probably haven't been careful enough in how you've done the experiments or the observations, because no hypothesis is complete and perfect. So always look for something to refine. And so that's a key component of steps 7 and 8 is, hey, if you're not refining something in your initial hypothesis, it means you've not done a very thorough job. And so, because the probability of you getting it exactly right the first time is essentially 0. And it's certainly 0 if you're saying, hey, do I have a complete hypothesis? And often that's what the refinement process is all about. Just saying, hey, this one idea or interpretation I had was valid, but I missed a few things. There's more going on here than what I recognize. And that's included in this idea of refinement. Often a refinement is an addition, but refinement means you're making minor changes. Revision means you're making major changes. And yes, there will be those cases where the change required is a rejection of the hypothesis. You go back to the drawing board. And I can tell you, there's been a lot of major discoveries in science where the scientists, the scientific team, they basically went through dozens and dozens of rejections until they finally came up with an hypothesis that had some validity. And as we say in science, and this also applies in theology, failure is often the most efficient way to make progress. Finding out what doesn't work, finding out what is wrong, often is the fastest way to finding out what is right. And so when we train scientists, and I think this is valid in theology as well, is don't crucify yourself over your failures. Failures are a crucial component of applying the biblical testing method. And God's going to tolerate you finding things that are wrong, and you might think you're wasting time, but in the end, you're going to say, hey, determining what is wrong can be a very effective way in determining what is correct. So step 9, determine how well the hypothesis fits with established understanding of related phenomena or texts. In other words, you may be looking at Genesis 1, for example, and trying to determine, okay, what is the sequence of God's creation activities in the physical arena? But you might want to test that hypothesis by saying, the hypothesis I developed here, how well does this fit God's intent, his purposes? So for example, the book I'm working on right now, I'm making the point that the science faith model that I think has the greatest opportunity for success is one where we do science from the perspective of God's intent to redeem billions of human beings from their sin and evil. And so looking at the phenomena that you're investigating, you say, okay, let's look at another phenomenon that has a high probability of being related to the phenomena I'm looking at. Or let's look at another Bible text. It may not be addressing science or creation, but it might be addressing something about God's purposes in creation and that might be related. I mean, an obvious example, you go to Genesis chapter 2. It's looking at God's creation activity from a completely different perspective, from a spiritual perspective instead of a physical perspective. The fact that the two creation texts, Genesis 1 and Genesis 2, are side by side, that's a big clue that they're related. And so going through Genesis chapter 1, developing an interpretation, saying, how well does this fit with Genesis 2? And how well does it fit in terms of integrating God's spiritual purposes in creating with his physical purposes? And of course, we do this all the time in science, where we're coming up with a hypothesis, say for the physics of star formation, and saying, how well does this fit into understanding of what works for planet formation or for galaxy formation? So you kind of go off a little bit target, look at something that is related and say, okay, how is this going to help me better understand the physics of star formation by going into planet formation and galaxy formation? Now you might think this is it. No, there's two more steps coming. So let's go to the two last steps. Number 10, you want to repeat all these steps for further insights, validation, or revision, or fine-tuning of the hypothesis that you developed. In other words, you've gone through these 9 steps, but it's based on the recognition, hey, we're never going to know everything about the phenomena we're investigating. We're never going to know everything about the biblical text we're reading and trying to understand. And only God's got complete knowledge. But God wants us to grow in our knowledge and understanding. So having gone through these 9 steps, we go back to step 1. So if I were to flip back here, having gone through the 9 steps, we go back and say, all right, based on these 9 steps, is there any need for me to adjust the phenomena we're investigating? Maybe I was too narrow or too broad in identifying these phenomena. Do I need to make some adjustments here? And then you go to step 2 and say, in light of these 9 steps, do I need to make some adjustment in the frame of reference? Is there something I've overlooked here in this frame of reference? And so, and then you go to step 3 and say, okay, how well did I do in identifying these initial conditions? And I'll share this with you. The first time I went through Genesis 1 at age 17, I only picked up 3 initial conditions from Genesis 1-2. The second time I went through the text, having applied these 9 steps, I went through and says, hey, there's a 4th one here. And having identified that 4th one, it made a major difference in how I interpreted everything else. And so, again, step 10, you go back to step 1, 2, 3, 4, 5, 6, 7, and say, okay, are there any adjustments here? Are there things that I've missed? You're not going to pick up everything in the first reading of the biblical text, or the first time you observe a star, or the first time you observe an animal in the field. So going through all these steps again, you're going to pick up more. So this is how the method works. You repeat all these steps for further insights, validation, or revision of the hypothesis. And sometimes you go through it a second time, you realize I was completely wrong. So often we see a reason to reject our interpretation on the first pass through. Sometimes it takes the second pass before you realize, oh, wow, I was way off here. And I need to completely reject and go back to ground zero. Or you might say, that revision I made, I shouldn't have made that revision. That what I thought was a revision really was a mistake, or the refinements that you make. And so you do this with a second pass through. Step 11, you never stop. You keep going through these steps again and again and again. There's no end to the application of the biblical testing method, AKA the scientific method. We keep recycling through this over and over again. But what happened there at UC Berkeley, by the time we're done with the weekend, all 30 participants, all 15 theologians, all 15 physicists agreed we're using the same testing method in physics as we do in biblical theology. We're on the same ground, and therefore we have a basis for communicating with one another, even though we've not been trained in both of these disciplines. We're using the same method. And I'm kind of out of time here, but I'll share this with you. Thomas Torrance, of all the theologians I've ever studied, he's written the most on the scientific method and how the scientific method that we apply in science is the same method that we apply in theology, and how he's actually commissioned through his Scottish academic press that he founded. They published a 28-volume set, basically documenting how what we call the scientific method has its origins in the Bible. I mean, we see this scientific method being displayed in multiple creation texts in the Bible, particularly evident in Genesis 1, as I'll show next week. But also, he says, Reformed theology. What happened in the Reformation is it wasn't just the priests that were studying the Bible. Now lay people had the Bible in their native tongue, in their language. During the Reformation, the Bible is being translated into English and German and French and other languages. And now not just the priests, but lay people were having access to the scriptures. And amongst those lay people were engineers and scientists, and they began to apply this biblical testing method in their scientific research. That was the birth of the scientific method. It was also the launch of the scientific revolution. And as Thomas Torrance so well documents in this 28-volume set that he edited, it's no accident that the scientific revolution exploded out of Reformation Europe. It was the Bible that gave birth to this. And Stanley Yockey, he's a Roman Catholic theologian. He passed away a few years back, but in his books that I've cited in my books, he makes the point that when you look at other cultures, non-Christian cultures throughout the history of humanity, you had bursts of scientific flourishing, but they're all stillborn. You see a brief flame, then it gets snuffed out. Only in Christianity do we see science being born, flourishing, exploding. The scientific revolution has been exploding since the Reformation. So for over 400 years, it has been sustained. In every other culture, any flame of scientific endeavor quickly got snuffed out. Not the case in Christianity. So with that, I'm going to stop the share feature. Actually, what I'm going to do is this. Let me pull this back a bit. This is the Zoom link you're going to need to get into the web meeting. We've been in a webinar. We always start with a webinar because it's very difficult to have someone come in to the webinar and disturb things. So that's the reason why we always have the web meeting afterwards. It gives us some control to prevent Zoom bombing. So we're going to exit the webinar, go into the web meeting. This is the URL you're going to need. It is posted at paradoxes.org. It's in the chat. And by the way, it's the same one we've been using in weeks past. So hopefully you've got that link there. And but when you get into the web meeting, you'll be put into a waiting room. Give me a minute to put you into the web meeting. And feel free to leave your cameras off and your microphones off and just communicate through chat, just like we're doing right now. But also feel free to turn your microphones on and your cameras on. And as soon as you do that, introduce yourselves to one another. And once we get enough people in the web, get them out of the waiting room, we'll launch the time and we'll begin the second round of Q&A. But also, I'm going to invite those of you who have a story to tell of a significant spiritual encounter you had in the past week or two to give a 1 or 2 minute testimony. And we'll alternate between a chat question and a live question through the microphone, and then we'll go to a testimony. So that's just going to happen. So with that, I'm going to stop the share feature. And I'm going to bring the webinar to a close, but I invite all of you to join us in the web meeting. So I'll see you there.